Now, deterministic push-down automata. We will look into the definition of deterministic push-down automata. A push-down automata M of Q, sigma, Q naught, A, delta, stack symbol, and then Z naught is deterministic if it satisfies two conditions. What is the first condition? For all Q belongs to capital Q, A belongs to tape symbols and X belongs to stack symbols. If delta of Q, A, X, has at most one move, it should have only one transition from every state, for every input symbol on every stack symbol. It should have at most one transition. That is what the first rule says. Second rule says that if for all Q belong to capital Q, A belong to sigma, and X belongs to tape symbol, if you have a transition for some Q, some A, and some tape symbols, if this exists, then for the same state, for the same stack symbol, epsilon transition, for epsilon there should not be any transition in the transition table. Let me explain these conditions with the help of example. Now consider a push-down automata. For designing a push-down automata for the language W is strings formed with A and B with the condition that the number of A's in W should be equal to the number of B's in W's. So I have taken an example in which the number of, it can be in any order, but the number of A's and B's should be same. The count of A and B should be same in the string, but it can come in any order, just like this example, B, A, B, B, C. Totally there are 3 B's and 3 A's. So we can take this as our example. So what algorithm we can follow is, for every B we have to count a and for every A we have to count a B. So whenever there is difference in symbols that is coming inside the tape, then in that case we will be pushing. Okay, initially whatever may be the state, if X is equal to, if X is pointing to a string that starts with A or B, whatever may be the condition, and if you have the stack as bottom of the stack, in that case we will push. So if your X is equal to A or X is equal to B, and if your Y is equal to Z0, in this case, if it is going to be A, then bottom of the stack, then B starting with string B, bottom of the stack, in that case we can push X and move X. We are going to push it. Now when you have a difference in symbol, when you have same symbols coming in, say for example, if your X is equal to A and top of the stack is also A, we cannot decide upon whether you have equal count. So we will be pushing in this condition also. When your top of the stack is B and input tape is also having B, in this condition also we will push inside the stack. Now when you have difference in symbols, that is, if your X is pointing to A and your top of the stack is holding a B value, or if your X is pointing to B and your top of the stack is holding a value, in that case you can have a count for A to B or B to A here. So we will pop off Y and we will move X. Now if you continue in this manner, then we will arrive at a case in which our X will be pointing to epsilon and our Y will be Z0. This is the condition for acceptance. In that case you can accept the string. So according to this algorithm, first if B Z0, taking this as example, if B Z0 is coming, so X is equal to B and Z0, it is rule first if condition, so we will be pushing. And then if A is coming next symbol, A is coming next, B is in the top of the stack now. Now for this B there is a count tallied with A. So third if condition is satisfied here. So we will pop this B. Now again your Y will be pointing to the bottom of the stack. Now again a is coming. Rule 1 will be satisfied. A is not. We will be pushing A now. Now next again B is coming. For this B, again A is in the top of the stack. Difference in symbol. For this B, there is a A here. So we will be popping off. So this A also get popped off. Again bottom of the stack. Here B is coming. I'm sorry. This B will be coming now. Now this B again you will be pushing. Now you have A. A is in the string input tape and B is in the top of the stack. In that case also we will be popping. Rule number 3. Again finally X will reach the extreme right and it will be pointing to epsilon while your Y will be pointing to Z0. In that case you will be accepting. So how can we give the transition? Q, sigma, tape symbols and then moves. So initially if Q0, A, Z0 is coming, if the string starts with A, then we will be pushing. Then if the string starts with B, in that case also we will be pushing it inside the stack. Now what is the other condition for push? If same symbols comes in, then we will be pushing it inside the stack. So same symbol in tape, and because we cannot decide on the count of A's and B's in that case. So if Q0, A, B comes, difference in, for this A there is a matching B on top of the stack. In that case we will be popping. Again Q0, B, A, in that case also we will be popping. Now what is the condition for acceptance? Q0, epsilon, Z0. In that case we will accept. So this is the corresponding transition diagram. Now according to the definition of deterministic pushdown automata, rule 1 says for every transition there should be only one move. So according to rule number 1, this pushdown automata is non-deterministic pushdown automata. It is not deterministic because for every transition, for each and every transition, it is having only one move. It is having exactly one move. So it is non-deterministic by rule number 1. First condition is not satisfied. Second condition is if for some delta of Q, A, X, for some input symbol and for some stack symbol, this condition exists, then epsilon, this for the same state and for the same stack symbol, epsilon should not be in the tape. So we will consider this epsilon transition. For this Q0, this epsilon Z0 exists. So for the same Q0 and Z0, some other tape symbol should not exist. But see here, for Q0, Z0, we have a transition with input symbol A and also B. So by rule number 2, this particular example is non-deterministic. Now we can change this into deterministic by simply changing the state like this, states like this. Now if we do the initial push when the bottom of the stack is Z0, during the first push we will change it to state 1. If the string starts with A, then Q1 A Z0. If the string starts with B, then Q1 B Z0. In that case, all other operations will be performed in Q1 state. So this all will be happening in Q1 state. If we change like this, then see here. So Q1 epsilon Q0 exists, but Q1 A Z0. There is a change in state here. So now this becomes non-deterministic pushdown automata. This becomes non-deterministic pushdown automata. It was previously this becomes deterministic pushdown automata now. Previously it was non-deterministic because this was also existing and Q0 epsilon Z0 also existing. If this exists, this should not exist. For the same state, for the same stack symbol, epsilon transition should not exist. So now we have changed it to this one. Okay, now it becomes deterministic pushdown automata. It is not having one move. It is not having more than one moves, and it is satisfying the second condition also. See here in definition, So all transition is having exactly one move. Yes, this condition is satisfied. Also, for some tape input symbol for the same stack symbol and same state, epsilon transition should not exist. Here it does not exist because the state, there is a change in the state. From Q0 it has been changed to Q1. By making this minor correction, we were able to construct a deterministic push-down automata. And that's all I have for this video. Next video, we'll take one more example for deterministic push-down automata. Thank you.